Good morning, class.
Good morning, sir.
So today we're looking at the SSGHS High School Grade 11 Mathematics Control Test 1. The control test that you guys have written, okay? So at this point you got your question paper and your memo. No, not your memo, but your script. The question paper and memo can be found in the description box below. If there's any problems with the way we mark, with the way Ms. Dixon marked, you just circle the question in pencil and then I will check. If you are supposed to be awarded the mark, you will get the mark. Okay? There's no issue. Alright, so let's go. So the first question, in this paper we covered Euclidean Geometry, surds and exponents, equations. Is that it? Yeah, equations. There was no inequalities in this one. Complete the following statement. A line drawn from the center of a circle to the midpoint of the chord is perpendicular to the chord. Not so. Perpendicular. In the diagram, so this is actually the application or the use of that theorem that we just looked at now. Okay. So in the diagram, AB is the diameter. People, if AB is your diameter, what do we know? That angle C is 90 degrees. Angle in C is but center O. Then we are told that chord AC is drawn such that AD is perpendicular to, equal to DC, which is equal to 48. So I'm just going to put 48 here and 48 here. OD is 14. That is 14. The question says calculate the size, write down the size of angle C. But we see that angle C is 90 degrees. So angle C is 90 degrees. Why? Angle in semicircle. So what we notice here now, we've got a right angle triangle, so we can calculate Pythagoras if needed. Not so. Determine the length of DE. So we know that OE is the same as the length of OA. Not so. Which is also the same as OB. But from the information I got, I can actually calculate the length of AB. Not so, by using Pythagoras. Can you all see that, people? So let's apply the theorem of Pythagoras here. Number 2. I'm going to say that AB squared is equal to, we don't have BC. Sorry? What? We have OD, so we must apply Pythagoras here. Not some. I thought I had BC. So you're going to calculate Pythagoras in the other triangle. So firstly we need to know that this is 90 degrees. Was it given 90? No. So I now need to say that angle D1 is equal to 90 degrees. Why? Bisector from center to chord is perpendicular to chord. Okay. So now we got 14, 48. So OA squared is equal to 14 squared plus 48 squared. Reason? Pythagoras with angle D1 equals 90 degrees. Okay. So okay, so we've got 14 squared and you've got 48 squared. Gives you 2,500, the square root thereof gives you 50. So OA is going to be 50 units, centimeters in this case. Okay. But remember, they wanted DE. But I know that OE is also 50. So DE is going to be 50 minus 14. And what's my reason here? Radius. Radius. So that's going to give you an answer of 36 centimeters. Okay. Any confusion so far? No? Please stop me, and if we come to a point where I haven't taught you that particular question. Right. 1.3. Here we are given that the circle with center O, the radius is equal to 10. So the radius of the circle is 10. Of course, that is not 10. Why? Because this line is not touching the circumference of the circle. We are told that OQ is perpendicular to PR. People, if OQ is perpendicular to PR, what do we know? We know that PQ is equal to QR. Not so. Then we are told that PR is 8. So if that is 8, then that's going to be 4 and 4, of course. And OQ is X, which is this length here. So if I conclude this triangle here, then I know this length is going to be also 10. Why? Right here. If I got 14, I can calculate X. Not so. The question says determine with reason the value of X. Okay. So, remember, whatever is not on the diagram, I must write it in. Okay. So we start off by saying that OP is equal to 10. Why? Radius. Then we told that this is 8. So PQ is equal to QR, which is equal to 4. Why? By perpendicular from center to chord by 6th chord. Okay. So we have 4 here. So now I can apply Pythagoras. Not so. So you're going to get x squared is equal to 10 squared minus 4 squared. Reason? Pythagoras with OQP equals 90 degrees. Okay? So it gives me 100 minus 16. We give you an answer of 84. So it's the square root of 84. So x is equal to, I think it's 2 root 421 or 9,17. Right, you guys understand? Is there any confusion? No. People, number 2. Question 2, sorry. The circle with center O and arc. People, this is a proof, not so. The proof can be found there are link to proof, you know. So the link to this proof can be found in the description box below. Okay. I'm not going to prove this again. Number 2.2. A circle with center O is drawn. A circle with center O is drawn such that POS is 60 degrees and PS is equal to TN. TN is equal to PS. People, if these lengths are equal, what do we know? We know that angle R is equal to angle S. Why? The polarities, which it says angles opposite, not angle. Equal angle, equal lengths subtends equal angle on the same side. Okay. Huh? That is derived from angles in the same segment. Okay. So with that, the question says determine the size. Okay, yeah, determine the size of PRS. So PRS. As you can see, PRS has a relationship with POS. Not so. And what's the relationship? is that angle at center is twice angle at circumference. You all see that, people?
Yes, sir.
So then PRS is equal to 30 degrees. Angle at center is equal to 2 times angle at circumference. Okay, this 30 degrees. Yes? This is 2.2.1. 2.2.1. Sorry? 2.1 was the proof. No, I'm not going to prove that. So I've done it already. And I'm going to put the link in the description box below as well if you want to go watch it again. I don't do proofs again in papers. It reminds me that the question paper and memo can be found in the description box below. Then I want you to calculate TSN. TSN, which is this angle here. But we know that that angle and this angle is the same. Not so? So you say TSN. Angle TSN is equal to 30 degrees. Why? Equal chords so obtains equal angles on the same side. Equal chords obtains equal angles on the same side. Okay? Question 3.1. Complete the following statements. A tangent to a circle is perpendicular to the radius of the circle. Okay. Opposite angles in the cyclic quadrilateral are supplementary. Or, if you had written 180, I would have also accepted that. Okay. Next question, 3.2. (3.2.1) 3.2 first. We are told that the circle below has a diameter AD. People, if that's your diameter, what do we know? That B1 is 90 degrees. Drawn through circle O. ADB is 62 degrees. And BC is equal to CD. If BC is equal to CD, what do we know? That A2 is equal to, B2 is equal to D2. Angles opposite equal sides. If it's a tangent to the circle at D, people, if this is your radius and this is your tangent, or your diameter and tangent, that angle is 90 degrees. Okay? So with that in mind, let's answer the questions. The first question says, calculate the size of BCD. BCD. For 2 marks. Okay, so angle C has a relationship with angle A. What's the relationship? Opposite angles are supplementary. Okay, so if I got angle A, I've done the job. But we know that angle B is 90 degrees. So angle B1 is 90 degrees. Why? Angle in semicircle. Okay. Then angle A is equal to 180 minus 90 minus 62. Why? Sum of triangles. And it is triangle BDA. Which gives us 28 degrees. Have I answered the question? No. How do I get then angle C? 180 minus 28 degrees, which is 152. Reason? Opposite angles are I think that marks it a bit too little for all of that work, yeah? But okay, it is what it is. Any confusion there? Huh? No? Then the question says, calculate CDF. Angle CDF. CDF. So it's actually D1. Not so. But D1 is the same as angle B2. Why? Tan-Core theorem. Not so. But how can I, B2 is the same as D2. Why? Angles opposite equal sides. Then I can actually work out D2 and B2 using sum of triangles. Not so. So let's go. Where do we start? We say firstly that B2 is equal to D2. Why? Angles opposite equal sides. Then twice B2. Or I can say B2 plus D2 plus 152. And then replace B2 afterwards. Equals 180y. Sum of triangles. And this triangle CBD. So B2 works out to be 180 minus 152. 180 minus 152 divided by 2. Angle of 14. Is that correct?
Yes.
14 degrees. So therefore, angle D1 or CDF is also 14 degrees. Why? It's a tan-core theorem. As you can see, this angle is equal to that angle. Okay. See any problems in this one? Okay. You're shocked that it's so easy?
No.
Yes, this is. People question 4. In the diagram, the circle to the center O is drawn. TAB is a tangent. So TB is a tangent to the circle at B, and TA is a tangent to the circle at A. Then we are told that BTA is 52 degrees, which is that angle. So this will show that question. We will show that TAB, so TAB, which is this angle here, is 64 degrees. So people, can I use 64? No, I can't use 64. I must end up with 64. Okay. So when we start, we firstly know that this is a tangent and that's a tangent. So what do we have? Tangents from common points. So I firstly say that TA is equal to TB. Tangent from common point. Tangent from common point. So that is equal. Which means to say this angle in question is actually equal to that angle there as well.
Yes.
Not so. So we now say that TAB is actually equal to the angle ABT. Why? Angles opposite equal sides. Not so? Let's take the box over here, the highlighted box. Okay. Now we can say that TAB plus ABT, which is the same, plus 52 is equal to 180. So I can just say twice TAB plus 52 degrees is equal to 180. Why? Sum of triangles, and it's triangle ABT. So you take it over the equal sign. So TAB is equal to 180 minus 52 divided by 2. say is 64. 180 minus 52 divided by 2, and the answer is 64. Alright, you guys understand? Right. Nothing out of the order, extraordinary yet, no? Whoops, we're missing a question here. Maybe this is, no. It's a different question. Huh? It's connected to that one. Yes? I'm going to get here because they say this is part of this. Okay, I see. Okay. Now the question says, so I got 64 here and 64. Okay. Yeah, let's pick up the pace a bit. How much time do we have left? And the bell rings? Yeah, sorry, did you get the reason? Oh, sorry. Okay. People, determine the size of BCA. BCA. For 2 marks. BCA. That's missing. There's a tangent, not so. So angle C is 64. Why? Tan quotient. Okay. Or you could have came from here as well, it's the same thing. Yeah? Then BOA. BOA, which is this angle. Angle at center is twice angle at circumference. Not so? So 4.2.2 is going to be AOB is equal to 2 times 64, which is 128. And the reason here it should have gone here, no? Those spacing is angle at center equals 2 times angle at circumference. Okay. So there it goes. 128. Is Zara going to go to Maslet now? I saw her this morning. I know she's here. Maybe she's going to Maslet now. She had to tell me if she's going. I don't have a problem if you guys needs to go. But first try. People, the next one. Determine the size of BOBA. Angle OBA. That is 4.2.3 OBA, which is this angle here. Not so? But we know that that angle stands 90 degrees with the radius. Not so, the tangent and the radius. So what do I say? That OBA is equal to 90 degrees minus 64 degrees. Why? Radius perpendicular to tangent. So I give you an answer of 26 degrees. Any confusion there? Huh? No? Right, now that brings us to the end of the geometry section. Question 5.1.1, solve for x. What do we notice here? It's already factorized. So I can just apply the zero factor rule. Set each bracket equal to 0. So x equal to 0 or x minus half is equal to 0. So x is equal to r. Any issues there? No? Look at the next one. People, the sum here, we can either use a quadratic formula or the factorization method that we are taught in grade 9. We take it over. X squared minus 7x minus 8 is equal to 0. Trinomial. X and x, 8 and 1, minus plus. So x minus 8 is equal to 0, so x is equal to 8, or x plus 1 is equal to 0, x is equal to negative. 5.1.3. People, when you see next to the sum corrected 2 decimal places, know that the quadratic formula is going to be applied. Okay? We take us over the equal sign. It gives us now 3x squared minus 2x minus 6 equal to 0. So what's my a value? Remember what's the formula? X is equal to minus b plus minus the square root of b squared minus 4ac over 2a. Okay. So what's my a value? 3. My b value? Negative 2. My c value? Negative 6. So x is equal to b, which is negative 2, so it's minus minus 2. Plus minus the square root of b squared, which is negative 2 squared, minus 4. My a value is 3, my c value is negative 6. Over 2, and my a value is, of course, 3. So because they say this here, right next to the sum, if you get the decimal wrong here, or you're for rounding off, you're going to lose a mark here. Okay. So let's work that out. We've got negative, open brackets, negative 2, plus the square root of negative 2 squared, minus 4a c over 2a. That gives us 1 comma 1 2. Is that correct? Huh? Oh, it's a negative. My mistake? 1 comma 7 9. Okay, thank you. 1.79. And of course the other one, replace that with a minus. Gives us negative 1 comma 1 2. Any confusion there? No? People, for this question here, you had to show your substitution. Eh? For the next one, your algebraic fraction. So when we start here, people, factorize this and swap this one around. Not so factorize. So it will be x minus 2 over x. We'll swap that around and negative comes out. 3 over x squared minus 3x. I take x out as a common factor. So x minus 3 equals x squared minus 4 over x as a common factor. X minus 3 minus 1. People, what's your LCM here? What is your LCM? X into x minus 3. What's my restriction? X can never be equal to 0 or x can never be equal to. So what must this denominator be multiplied by to get the LCM? X minus 3. So x minus 2 into x minus 3. Minus 3. What must this be multiplied by? 1. Equals. This must be multiplied by 1. Minus. This must be multiplied by the whole story. Not so. So it's going to be 1 in x into x minus 3. Okay. So what do I do from here? Tidy up, get rid of the brackets. X times x, of course, x squared. X times negative 3 is negative 3x. Negative 2 times x is negative 2x, which gives you then negative 5x. Negative 2 times negative 3 is positive 6 minus 3 equals, you multiply the 1 in, it's not going to make a difference there. Minus, multiply that in, and then of course get x squared plus 3x. People, x is one side, numbers the other side. Not so, because this is the leading coefficient is 1 here. And it's positive, so I'm going to bring everything to the left. If you had taken everything to the right, no problem, then I would have had negative x squared. You just divide by negative afterwards. So it gives me x squared minus 5x plus 6 minus 3 plus 4 minus 3x is equal to 0. Did I make a mistake? No? No. Okay? So it's x squared minus 8x, that is 10, 7. Is that correct?
Yes.
So my factors are, again I can either use a quadratic formula or I can use the old-fashioned factorization trinomial. So x minus 7 is equal to 0, so x equal to 7, or x minus 1 is equal to 0, so x equal to 1. People, does that overlap with any restriction there? No. So that's my answer. Okay. Let's do the next one. So we got the square root of 2x plus 1 equals x minus 1. So what do we do first? Square both sides. Get rid of the bracket. As you can see, the root is already isolated. It's already on its own. So by squaring both sides, that cancels. It gives me 2x plus 1 is equal to first term squared, x squared. That times 2 is negative 2x, and the last term squared. So what do we notice now? A trinomial. Take everything to one side. So 0 is equal to x squared minus 2x plus 1 minus 2x minus 1. Which now gives us x squared minus 4x. And that cancels. Not so. What type of factorization can happen here now? Common factor of x. So it's less with x minus 4. So therefore x is equal to 0 or x is equal to 4. But what do I have to do here? Remember, when we're busy with square roots, we must check if it works. Not so. So let's check on the side here. We don't have to show this calculation. Okay, in the test, we're going to substitute 0 in. So it's going to be your left hand side is equal to the square root of 2 times 0 plus 1 gives me 1. The right hand side is going to be 0 minus 1, which is, people, is 1 the same as minus 1? No. So that is not a solution. And if you forgot to put a line there, please let me know. You should lose a mark. Okay. And then on the other hand, you're going to test for 4. Go for the left hand side. It's going to be, as I said, you don't write this down. Okay. So that's going to give us, you can just run it on the calculator. It's 3, and the right hand side, of course, is going to be 4 minus 1, which is, and this one works. So therefore 4 would be your only solution to that equation. Okay. People, simultaneous equations. Quite a bit of marks here, 6 marks. So solve x and y simultaneously, which means to say at the same time. So what we're going to do is we're either going to make x the subject of the formula, or we're going to make y the subject of the formula. In this one is going to be easier. Okay? But between the two, it's actually going to make the easiest and the most sense is to make x the subject of the formula. Because if we're going to make y the subject of the formula here, we're going to work with a fraction. Not so. We take it over the equal sign, so x is equal to 2y minus 2. So what do I do with that? I substitute that into the first equation. It won't go back into the same equation, otherwise we'll get 0 is equal to 0, which is an identity. So if I say x, I put the 2y minus 2. So 2y minus 2 plus y equals x is 2y minus 2 times y. So what do I do is I get rid of the bracket now. This now gives me 2y minus 2 plus y is equal to 2y squared minus 2y. As you can see, the leading coefficient here is positive 2, so I take everything that side. So 0 is equal to 2y squared minus 2y minus 2y plus 2 minus 1. Which now gives me 2y squared minus 5y plus 2 is equal to 0. Again, what do we notice? Trinomial. 2 ways of factorizing it. How? Quadratic formula or the old-fashioned factorization method. Not so. So it's going to be 2y times 2 is 4 plus 1 is 5. Both is negative. So y is equal to. This is a note here. When we did that formula, I reminded you, if you're calculating y, you don't write x. is equal to in the using the formula, and somebody did it again. Okay, but just watch out for that. So 2y minus 1 is equal to 0. So 2y is equal to 1 divided by 2. Y is then equal to half. Or y minus 2 is equal to 0. So y is equal to 2. So what do I do with that, people? I substitute that into the third equation there. That has x as a subject of the formula already. So I say x is equal to 2 times y is half minus 2. He's going to give you 1, so he's going to give you negative 1, not some. Or on the other side, we say x is equal to 2 times, and your y value is 2 minus 2. 2 times 2 is 4, and 4 minus 2 is 2. So there are your 2 y values, and here are your 2 x values. Okay. Any confusion there? Huh? No? Question 6. Express m in the form of. People, that is what you need to do here? Complete the square. Not some. Or is in the turning point form. So we're saying that m is equal to. What's the first step we need to do in completing the square then? Take out negative as a common factor. Then I'm left with x squared minus 3x minus 1. So say okay. To get a perfect square trinomial, I must add a number. Not so. And that same number must subtract minus 1. And what is the number in this case? It's going to be b times half, and it must be squared. And what's your b value here? Negative 3. So negative 3 times half is negative 3 over 2, and it must be squared, which is 9 over 4. Or you could have just dropped the negative there, knowing that it's going to be squared anyway. So of course this is a perfect square trinomial here, not so? So it's going to be negative into x minus 3 over 2 squared minus, if I subtract it, I'm going to get 13 over 4. Is that correct?
Yes, sir.
Right. So what do I do now? Put the brackets there. There's negative into x minus 3 over 2 squared plus 13 over 4. Okay. Well, with the 3 marks there. Then it says, is m a maximum or minimum value? So we know that because of that being negative, if we're looking at x minus 3 over 2 squared, this will always be greater than or equal to 0. Not so. Then, with a negative in front, of course the inequality now swaps around, that will be always less than or equal to 0. Okay? And you add 13, the graph goes up 13, so it's negative x minus 3 over 2 squared plus 13 over 4. Has to be less than or equal to 13 over 4. Not so. So what does that tell us? That this graph actually has a maximum value. Okay? The maximum value. Because everything else is less than that. Okay, there's a maximum. Sorry. It's a maximum. Yes. Maximum value of 13 over 4. Write the value of x for which p will have a maximum minimum, and therefore x is at 3 over 4. Now some of you won't understand that, but what we do is we draw a graph. Not so. Is it a smiling or frowning graph? Frowning. The turning point there, of course, is 3 over 2, the additive inverse of that, and 3 over 4. So we say the graph has a maximum value of 3 over 4, 13 over 4, and occurs at an x value of 3 over 2. Okay. Let's go to the next one. Here we are told that the farmer wants to fence of his cattle within a rectangular area. The length of the area is given as the length of the area is given as x kilometers, and the width of the area, of course, y kilometers. It has 18 kilometers of fencing. Show that that y is equal to 9 minus x. People, fencing would be area or perimeter? Perimeter. Not so. Because what's going to go on the outside. So if this is a rectangular, then this length is x and that length of course is 1. How do you calculate perimeter of a rectangle? 2 length plus 2 breadth. So in this case, the perimeter is 18 is equal to 2. Your length is y. The length of x, sorry, and your breadth of, or your width of y. So as you can see, y is the subject of the formula here. So what do? I take that over, so 2y is equal to 18 minus 2x divided by 2 is going to give you 9 minus 8. Not so. Then the question says,
all matrix, can you please report to Ms. K. Dixon's classroom? All matrix, please report to Ms. K. Dixon's classroom.
okay.
All Bengal Forest, can you please meet Ms. Nkomazake in the classroom?
This is write the formula for the area. How do you calculate the area?
Ms. Nkomazake in the classroom now.
So what's the length? X, and the breadth of course is y, which is 9 minus x. Get rid of that, so it's going to be 9x minus x squared, or minus x squared plus 9. Okay. Then we are told what is the largest rectangle area that can be enclosed with an 18-kilometer fencing? Okay, so on Monday we'll wrap this up. Okay, I don't think we have much left. We have another question left, isn't it? Yeah, okay, rather do it on Monday. If you have any problems, just circle the question for now. We will come back to it Monday. Okay. People enjoy the weekend. Good morning, class. Okay, good morning, class. So today we're looking at the second half of the control test that you guys have written. It was for 2 hours and it was 100 marks. So at this point we got up until question 6, 7, 6. There's a marker here. So the next question is, what is the largest rectangular area that can be enclosed with an 18-kilometer of fencing? So we have used the 18-kilometer already. So when we work out the area, we got 9x minus x squared, or negative x squared plus 9 as the area. There's the algebraic expression for the area of this rectangular shape here. Okay. So if it's asking for the maximum or the largest, of course we need to complete the square. Okay. Question paper and memo can be found in the description box below. So in other words, the area is going to be negative x squared plus 9x. To complete the square, first take out negative. I always get the 1 in front of x squared as the coefficient. Negative, so it's going to be x squared minus 9x. We ask ourselves, okay, what must be added to complete the square with? It's going to be b times half, which is 9 times half. It's 9 over 2, and it must be squared. So it's 81 over 4. Which now gives us negative into. It's a perfect square trinomial here, and that's what I built there. So it's x minus 9 over 2 squared minus 81 over. So we get rid of the bracket by multiplying out, so it's negative into x minus 9 over 2 squared plus 81 over 4. So the question is, what's the largest rectangular area? So therefore 81 over 4 kilometers squared, or 20 and a quarter kilometers squared, or 20, 25 kilometers squared. All of those would be acceptable then. Okay. See any confusion? Okay. Let's go to the next one. 7.1, they ask you to simplify without the use of a calculator. You answer with positive exponents. Positive exponents. Okay. So firstly, I'm going to simplify that inside of it, okay? That can be written as 1 over b to the exponent 2 over 3. And it must be raised to the exponent negative 9. So 1 to any exponent remains 1. However, b 2/3 multiplied by negative 9 is going to be negative 6. You all agree with that? So because the exponent is negative in the denominator, bring it up, becomes b to the 6 over 1, which is b to the 6. Okay? Just let me know if I'm making a mistake, or you need some clarity on something that you've done. Okay? The 3 marks, 7.1.2, they ask you to simplify. Okay, so assuming you apply this distributive law there. So 2 root 2 times 3 root 2, 2 times 3 is 6, root 2 times root 2 is 2. 2 root 2 times 12, 2 times 12 is 24 root 2. Negative 1 times 3 root 2 is negative 3 root 2. Negative 1 times positive 12 is negative. What is 2 times 6? 12. So that cancels. Not so. 24 root 2 minus 3 root 2 is 21 root 2. Okay. The next question, 7.3. So again, we're going to, since we're multiplying and dividing, so we're going to make the bases the same for the exponent, and so that we can either add or subtract the exponents. So we've got 2 cubed x times 16 can be written as 2 to the 4. For those of you who don't know, we got that. You say 16 equals shift. You see this button here with this dot and this colons here, which you use in geography. You press the button, you get 2 to the 4. Likewise, 8 2 cubed. Alright, that's going to give you 2 to the 4 raised to the x plus 1 times 4 is 2 squared to the negative x over 2 cubed raised to the 2x minus 3. So what do we do now, people? We multiply the exponents. It's going to be 2 to the 3x times 2 to the 4x plus 4 times 2 to the minus 2x over 2 to the 6x minus 9. Not 6, 9. 3 times 3 is 9. So when we're multiplying and bases are the same, what do? Add the exponents. So it's 3x plus 4x plus 4 plus minus 2x, which is minus 2x. Bring minus 6 up, it becomes 6 up becomes minus 6x. Bring negative 9 up becomes plus 9. Okay, so now 3x plus 4x is 7x. Minus 2x is 6x, 5x. Negative x. 4 plus 9 is 30. So it's 2 to negative x plus 30. Is that correct? Okay. Positive exponent. I think they gave you full marks there. But if you want to write the positive exponent, it's going to be 2 to the x in the denominator because it's negative in the numerator, and 2 to the 30. Or 2 to the x minus 13 in the denominator. Either one of those will get you full marks. Okay? 7.1.4. So here we have a negative and positive between it. So what do we need to do? Break it up and factorize. That's simply going to give us 2 to the x times 2 to the minus 3. Minus 3 times 2 to the x. So this is all over 2 to the x plus 2 to the x times 2 to the negative 1. So what do we notice here? 2 to the x is a common factor. So what am I left with? 2 to the minus 3 all over 2 to the x into 1 plus 2 to the minus 1. So what happens? 2 to the x cancels. So 2 to the minus 3 is 1 over 8 minus 3 over 1 plus half. So it's 24 is negative 23 over 8. Must be divided by 3 over 2. Negative 23 over 8 must be multiplied by 2 over 3. I tumble then times there. 2 going to 2 once, 2 going to 8 4 times. So it's negative 23 over. Otherwise you could have put this whole story into the calculator. And I'm sure you would have gotten that answer. Sorry? Without the calculator. Okay, you can check with the calculator. The next one, 7.1.5. So here we got 2 root 5 minus 10 over root 5. So what do we need to do first? Rationalize the denominator. Not so. So to rationalize this denominator, multiplied by root 5 over root 5. Sorry about this. They look like they're still on holiday. Okay. This is a reset program. Sorry about that. Okay, so we're going to rationalize the denominator by multiplying this by root 5 over root 5. Remember, we want the denominator to be rational. So it's 2 root 5 minus root 5 times root 5 is 5. 10 multiplied by root 5 is 10 root 5. Okay. So 5 into 5 once, 5 over 10 twice. So it's 2 root 5 minus 2 root 5, which is 0 root 5, which is 0. Okay. Next one is question 2, 2.1. (7.2.1) Solve for x. Yes? Okay, so 4 can be written as 2 squared raised to the x plus 8 minus 9 times 2 to the x equals 0. But we know that this here 2 to the 2x 2 squared raised to the x can be written as 2 to the 2x, which in turn could also be written as 2 to the x squared minus 9 times 2 to the x plus 8 is equal to 0. So what do we notice here? We can say trinomial is let 2 to the x equal k. So I have k squared minus 9k plus 8 is equal to 0. Trinomial, we could use the formula. So I got k and k, 8 and 1, both negative. So k is equal to 8 or k is equal to. So what is k? 2 to the x. So 2 to the x equal to 8. But 8 can be written as 2 cubed. So therefore, x is equal to 3. On the other end, we have 2 to the x equal to 1. But 1 can be written as 2 to the 0. So therefore, x is equal to 0. So x is either equal to 3 or x equal to 0. Okay, the next one. Got 9 to the exponent 1 over x is equal to 243. But 9 can be written as 3 squared, not so. Raised to the 1 over x is equal to 243 can be written as 2 to the 3 to the 5. Remember, this is your exponential equations. We want the bases to be the same for the exponents to be. Multiply that in. So go 3. 2 times 1 over x is 2 over x is equal to 3 to the 5. When bases are the same, exponents are equal. So therefore 2 over x is equal to 5 over 1. Cross multiply. 2 times 1 is 2. 5 times x is 5. Divided by 5 both sides. So therefore x is 2. Okay. Next. If did I change the sum? Okay, so if m plus 1 over m is 5, determine the value of. So what they do is we have x squared, m squared plus 1 over m squared. If we look at this here, we've got m plus 1 over m is equal to 5. You can see it's clearly squares there, not some. So I square both sides. So I have m squared plus that times 2. So it will be 2 plus 1 over m squared is equal to 25. Not some. Which now gives me m squared plus 1 over m squared is equal to 25 minus 2, which is 23. You will agree with that? Any confusion there? No. Okay, so the next one is 7.3.2. We are given m squared over m4 plus 1. We must determine the value of that. Okay, so what I notice is that somewhat or other, this is basically the reciprocal of this here. Can you see that, people? So if I found, you say we let this equal to a. Okay? So what they did was they swapped this around. Okay? But take the reciprocal there, I must take the reciprocal on the other side as well. So it's m4 plus 1 over m squared is equal to 1 over a. Okay? So, if I put each one of its own, it will be m squared plus 1 over m squared is equal to 1 over a. But what is m squared plus 1 over m squared? 23. So in other words, 23 is equal to 1 over a. Cross multiply. So 23a is equal to 1. So a is 1 over. Okay. And then of course, is there a bonus question? We are told that if 4 to the x is equal to 10, without using a calculator, without solving for x, determine the value of 16 to the exponent x plus 1, 5. So firstly, I'm going to try and get 4 to the x there. That's my first thing. Okay? But we know that 16 is the same as 4 squared. Not so. It's 4 squared raised to the x plus 1.5. So I multiply, get rid of the fraction, bracket, sorry. So it's 4 to the 2x plus. Now 2 times 1.5 is 3. Okay. What I do is I say, okay, you got 4, I break it up there because I have 4 to the x and I want 4 to the x standing on top. Times 4 to the 3. But now this here can be written as 4 to the x squared times 4 to the 3. You all agree with that? So what is 4 to the x? 10. So in other words, I have 10 squared multiplied by 4 cubed, 64. So 10 squared is 100 times 64, which is 6400, or 6400. Question paper and memo can be found in the description box below. Okay.